this video, we'll be discussing the area between the curves. So one key thing you need to understand when finding the area between curves is that you need to understand which function is at the top and which function is at the bottom. And once you have that understanding, you'll take the integral of the interval from a to b. So the integral from a to b of your top function, so this will be your top function, minus your bottom function, which we'll refer to your bottom as g of x. And what I mean by your top and bottom function is if you were to graph these functions, which one is on the top and which one's at the bottom. For example, if we have a simple xy chart and we take a simple trigonometric function, let's say cosine, and we're going to bound our domain from the y-axis to pi over 4. So we have our cosine function from here, and then we'll have our sine function, which goes something like this. Right, so we know our bottom function would be g of x, which is equal to sine of x. And our top function we refer to as f of x, which will be equal to cosine x. So we can rewrite this in terms of the integral because we bounded it from the y-axis, we'll say from 0 to pi over 4, which this should honestly be closer to the intersection. So this should be right here with they intersect, which should be pi over 4. So that pi over 4. And then we're going to take our top function, cosine of x, minus sine of x, dx. And then we would proceed as normal, as a normal integral, right? So the key thing to understand here when you're finding the area between the curves is you need to understand where your domain is being restricted and your points of intersection. Because the thing with the trigonometric functions in this case is they have an infinite amount of intersections. So as the graph as the graph proceeds, or as you move along the x-axis, either left or right, you'll always have an intersection between sine and cosine. So you need to understand that your interval from a to b are the intersection points of the two graphs. So they're either the intersections, right? Because in this case, b, right, this point, pi over 4 is the intersections, or the point at which your domain is being restricted. In this case, we're restricting it to 0. So this finds the area between from this point to this point. And if this doesn't make sense, let's look at it at a more graphical lens. So if we're just given this quadrant and we understand that this is our cosine function and this is our sine function, right? It may be helpful if I draw in a different color. So we say this is our sine function and this is our cosine function, right? So what we're doing here is we're taking the area below the curve of our top function, which would be cosine, which would be all this area below the curve. And then we're subtracting the area, we're subtracting the white area. So we have area A. We'll call this area A, right? So area A. And in our bottom function, we're taking this area and we'll call this B. So we're basically subtracting area B by area B. And this will give us this area. And that's how it works because we understand our top and we understand our bottom functions, and we're able to remove this area so that we can get the area we want between the curves. So when you're dealing with a problem that requires you to find the area between the curves, it's important to understand how each function looks when you graph it. So I'd always recommend attempting to graph and find the boundaries of the shaded region, as we just did here in this example. And once you understand this, right, once we've understood like graphing it and looking